We often come across several forms of unstructured data in context of machine learning and work on unstructured data as the input for several machine learning problems. The most important class of unstructured data we deal with is the text data. We see text data in various sources, whether coming from social media like text in Twitter, Facebook, etc., or coming from blog reviews, or coming from a lot of scientific literature like research documents or medical literature, etc., or several textbooks or digital textbook or digital content or website contents. So name it, and we have several text corpora available for us in form of what we get as input for doing several machine learning work on. So what text analysis usually refers to is text analytics as a field is basically a field of analytics which deals with text as input. It can be a series of techniques or a whole bunch of techniques which is not necessarily all ML based. Some of them are ML based, some of them are non-ML based, but idea is you use them to work on text. And they are actually built on conventional computational language-based techniques known as natural language processing. So natural language processing, in fact, I would say probably predates machine learning. The techniques in handling human language in natural language processing have been there in even days before we had very developed machine learning algorithms. So in that sense, we can say that if you look at NLP and ML as two entities, it's like there is definitely an intersection, but it's not necessary that ML is required for NLP or NLP is required for ML. For example, ML can work on non-text data, structured data, right? But for doing NLP today, the predominant set of techniques are consisting of using ML and variants of ML, let's say for text classification, like in spam classification, or in text clustering, like in keyword training, etc., using ML-based unsupervised learning techniques on text corpora. So what we need to understand is, if you look at from the Venn diagram perspective, this is how it looks. But what is actually required for us, if you want to look at applying some kind of analytics on text, that's where we have several sets of techniques which are useful in the context of text analytics or natural language processing, which are useful for processing structured or unstructured text. Structured, I'm saying, is because sometimes text fields in structured data can also be text, and they can be used using the standard, things like clustering using edit distance or something like that. Now, coming to how you work with text data in natural language processing, or we call it text analytics or text mining, we have what is known as text mining pipelines. Text mining pipelines are basically nothing but sequence of different activities which can be performed on input text in order for running ML algorithms on top of it. So let us look at some of the prominent concepts or stages in text mining pipelines. And before that, let's understand there are two different kinds of mining that can be applied on text mining. One we call it as syntactic, another we call it as semantic. Syntactic analysis is purely based on syntax of the text. There is no concept of meaning attached to any word or any kind of anything beyond what is present in the actual paragraph or the text corpora which are consisting of. And in semantic, we are worried about inherent meaning of the text going beyond what is written there. It may be in form of understanding emotion, or understanding sarcasm, or understanding if two words are talking about the same thing, or different semantic entities can be formed, information can be obtained from the same text. In terms of syntactic analysis, we usually worry about understanding the content of the text, parsing it, and then using that same thing for different purposes, like how we want to target machine learning problem. So let us look at different text mining pipeline stages and the different processing work or different kinds of processing which is done on text mining. It's not that you need to apply all the stages, but some stages are required in some problems, in some stages are not required in some problems, or some stages may be mandatory, or some stages may be optional. To start with, let's look at syntactic pipeline. In the syntactic pipeline, usually you're given something known as a body of text, which we call it as corpora or corpus of text. Corpus of text is basically a large collection of sentences, which is the natural language text. And the first element which is useful in syntactic analysis and text mining is what is known as tokenization. Tokenization is nothing but it is basically a way of breaking the entire set of sentences into individual words. Say, for example, you say Ram is a boy. So we're breaking it into 4 words. The tokenization can be at multiple levels. It can be tokenizing at word level, it can be tokenizing at paragraph level, sentence level. But any NLP toolkit will be able to give you a tokenization approach for breaking the whole input data into a set of tokens. So this is the first step usually in form of syntactic analysis of any word, any sentence or collection of sentences. Then you have different other pre-processing techniques. Like, what typically happens is there are a lot of words that are very frequent in English language and do not add any value to the sentence. Like of, is, or, am, he, she. A lot of words which are basically very common. And these are called stop words. And you typically would like to remove stop words from the original text before you want to make any further sense of the original data. So what happens is stop words elimination is an important pre-processing step for any large text corpus. Then beyond stop words, we want to look at see if there are variations of the same word by using one of the two, either stemming or lemmatization. By stemming, we mean when you have variants which are based on, say, tense, like horses. Can you remove s and bring it only to the root word? Or going, can we remove the going and remove it, bring it only to go? Because variants of the same, because of tense, number, etc., do not add any meaning. So we typically stem the words to the root words. But stemming is purely syntactic and sometimes can be problematic. So it sometimes creates problems. But lemmatization is a more stricter form of stemming where we get more meaningful root words of the same thing. So it is not very dumb grammar-based splitting into root word, but actually it goes to the root word of each, and it actually can remove more meaningfully to the corresponding root word. So sometimes you may stop at stemming, you may want to, sometimes you may go to lemmatization. But the idea is, ultimately, the whole goal is to reduce the amount of work you need to look at working on the original input, concisely summarized into data that can be fed into ML or any text mining algorithm. Now, once you have this, then you actually can do several other works which are, depending upon what you want to do, will vary. For example, if you just want to create something like a word cloud, all you need to do is, you need to take the outputs of this pre-processing, then you have really a lot of stemmed words, and then draw something like a frequency chart of most frequent words in decreasing order of frequency, then assign it to a word cloud library and create a syntactic sugar of the word which is most frequent and the most darkest, right? This is one use case. Another use case where we may want to look at specifically identifying what are the nouns being talked about, or what are the verbs or actions being talked about. There we use something known as parts of speech tagging. So parts of speech tagging is basically an external dictionary of different parts of speech which can be used to parse the sentence to understand what is a noun, what is a pronoun, what is a adjective, what is a adverb. So here we have actually a very complex collection of pause formula. For example, there may be something known as a typical literal noun, then there will be something known as a literal noun phrase, then there will be something like which is a determinant. So there is a broad collection of 30, 40 different parts of speech, detailed glossary which has been done by experienced text processing or natural language processing specialists. So what you do is you pass the set of words output after this and pass it to pause tagging, and this may help you in understanding what are the different parts of speech, what are the different verbs being talked about, what are the different adjectives being talked about in a standard sentence. This is one use case. So I'm saying that in terms of NLP, use case determines what level of analysis you will be doing. Then suppose you have another use case where you're talking about, identifying all the medical terms which are related to all the terms in the medical dictionary coming from there. So there we use a technique known as named entity extraction, which is basically named entity means, suppose I want to find out all things which are related to medicine, all things which are related to symptoms. So we may have dictionaries which are corresponding to symptoms or medicines from medical dictionary, and then use it to run after, say, pause tagging has been done, then go after nouns to get maybe some of the medicines or some of the characteristics which are adjectives to go into symptoms, and you can use this as a key business use case depending upon your requirement. In several business cases, we use named entity extraction as a target business use case. This is one use case. Then from here, there is one more thing we can do is, while looking at frequency chart is a very good idea from understanding this relative syntactic presence of the different words in the document, there is another useful way by which you can understand which words are useful in context of a word in a document. It's called TF-IDF. TF-IDF is technically very simple. It says that for a given term and a document, what is the term frequency of that term in that document, means how many times the term occurs in that document, times number of documents, total number of documents, divided by number of documents containing T. So this is basically inverse document frequency, which says that the total number of documents is some n and only some part of it contain this particular term, then this is basically an inverse of that. Or you can actually usually use log of this also in cases. But the idea is that if it is too common a word, it is present in all the documents, it is less important. Like a common word like is, all, are, etc. Whereas if it is contained in only very few, means it is relatively more important than others. So that way, it is dampening the effect of playing down frequency by looking at how important it is. And TF-IDF is a very common word which is used in the context of understanding the different importance of terms in each document. Now, coming to ML, what is the role of ML in all of this? So there are several use cases of ML. For example, in named entity extraction, we can use earlier method of tagging a whole bunch of symptoms and corresponding words as default data and create a classifier and pass it to the new sentence that is coming in to identify the corresponding named entity like say the symptoms. So what happens is ML interspersed with text processing techniques gives rise to many different use cases. For example, if you were to look at say spam classification. In spam classification, you will first pass your email text through some of these pre-processing stages. Then it is possible that you will come up with TF-IDF values for each of the words, and you will create a structure where you have several documents and several words, and you create something known as term document matrix. And content of each will be the TF-IDF of that word corresponding to that document. And this can be your input, and that, you can flag it, saying that that document has been flagged as spam or non-spam. Spam. So this becomes an input for a spam classification where from the original data you created a term document matrix where there is documents, terms and TF-IDF of each corresponding output as spam or ham corresponding to it, and this becomes the input for your corresponding spam classification. So what we've done is we've actually used text mining plus ML for spam classification. So we've seen that if you look at from the perspective of how you want to deal with unstructured data like text, you may use a simple unsupervised requirement like a word cloud, or you may use a simple supervised scenario of building classifier for basically identifying symptoms, or you can use a classifier like spam classification where you do a pre-processing with TF-IDF from the text and run a classification task on top of it. So if you see, there are multiple tools coming out. Text processing is independent of ML. There is several workings happening on text itself. For some use cases of text and NLP and text mining, there is a need for using ML. For some, there is a need for doing a lot of textual pre-processing and using techniques like TF-IDF, which can then be fed into spam. So it's a whole jungle out there, so there's no one rule fitting all.